Augmented Hearing is a health tech startup which works on enhancing sounds you want more of and try to attenuate what you would rather do without. That's because lots of people have trouble understanding speech in challenging environments. And if we combine the built-in microphones in hearables like the Apple AirPods Pro with machine learning models running on the smartphone, we can of course personalize audio and try to use the digital signal processing in various ways to enhance sounds. But we are not limited to that. Actually, as you know, smartphones come with built-in natural language understanding as what we use normally if we talk to digital assistant like Siri or something like this. However, that probably depends on how noisy the surroundings are. And therefore, to really go in and work on enhancing sounds based on natural language understanding, this thing here from Facebook AI just released a couple of weeks ago seems to be very interesting. So this is a model which can actually learn from raw audio. And this means that you feed in wave signals into a convolutional network, and then that network will learn latent representations of audio. These are very small snippets, 25 milliseconds long, so even smaller than a phoneme part of a word. And then that goes into a transformer, so a bidirectional encoder like BIRD, but instead of having text, it works with these little sound features here. And then it will mask half of them, and the task of the network becomes to predict what are the missing ones here. It does that quite well. As you can see, if you look at the column to the very right, this is one of the new pre-trained models here, the Wave2Vec 2.0, where it has been trained on 50,000 hours of audiobooks, but that's unannotated, so that's not hard to do. What takes time is, of course, to go in and work with annotated data where you know what's actually being said. And in this case, as you can see, it works on just 10 minutes of annotated data to fine-tune the model. And that compares with what you have to the left, that you would normally work with hundreds of hours of training for having a equivalent performance. If you would like to work with this, you don't need to start from scratch. There's a GitHub repository, and you have pre-trained models. There's lots of training data and ways to work with this. There's also the original paper, as you can see, where it's described how to work with this. But you could then go in and fine-tune on, say, 10 minutes of your own stuff. And what would that be? Well, that depends on what you want to attain, I guess. But it could, for example, be that maybe you wanted to train on voices which you listen to a lot. So people you are with normally, if you train on their voices, maybe it will come much easier for an encoder like this to recognize them in a noisy environment. It could also be that you wanted to create encoders which were really good at recognizing speech in different environments, and then you could maybe train on some of these environments. That's really up to you. But if you would like to work with us, don't hesitate to get in contact.